Hello everyone. So the question was a point charge inside a conducting sphere of radius r as shown in figure, right? Calculate electric field at point B00 which is here. Now one thing you need to understand is that it is a conducting sphere. So whatever you charge you put inside it will come outside, okay? And distributed uniformly. So that's why this charge will be counted and this point is away from this charge by the distance b, so that simply we can write it as electric field E is kq upon b square, or we can say q by 4 pi epsilon naught b square. So that will be the answer. Moving on to next question. So the question was radius of a charged sphere varies with time as r plus a cos omega t. So calculate average power radiated. So now we have to find the average power radiated. So first thing you need to understand is that its radius is expanding as r plus a cos omega t. But let's say its initial dipole moment was 0 here. Okay, obviously, so its power radiated will be 0, so that will be the answer. Now moving on to next question. This question was from quantum mechanics. The question says that a system has energy Hamiltonian this. Okay, calculate the energy for system for L is equal to 2 given L1 is equal to 1 and L2 is equal to 1. So here we need to find out the energy. Just Hamiltonian was this. Okay, so first of all what you need to understand is that there are two angular momentum L1 and L2, and from there we can find out this capital L, which is nothing but L1 minus L2 plus L1 plus L2, and it will give us 0 1 2. Now we know that these are the angular momentum operators. Okay, and we also know that L1 dot L2 is equal to half L square minus L1 square minus Lz square. So here we can write this Hamiltonian in terms of this L square operators. Okay, so first of all multiply this L2 with this 2 1. Okay, which is, I think it is Lz. So L1 Lz plus L2 square minus Lz square, which is basically we are putting this thing over here. Okay, so it will give us this expression, and after this we know that what is the I mean, if L square operates on sign, it will give us nothing but L plus 1. Okay, so that is how we will write it. L plus 1 for L1 square, it is L1 plus 1, and Lz for L2 it is L2 plus 1, and again for L2 it is L2 plus 1, and for Lz square it will be minus m square, because we know that if Lz square operates on the function it gives us m square h cut square. Okay, Lz basically give us m h cut, and we took this h cut square common from all these thing, and it will get cancel out this with this. Okay, and after putting all these things we get this expression L is equal to 3 minus m square. Now we know that for L is equal to 2, m can take values from minus 2 1 minus 1 0 1 2, and by squaring it we will get 2 square 1 square or 0. Okay, by putting these values we get three values, 3 epsilon, 2 epsilon, minus epsilon. So that was the answer. Sorry. Now moving on to next question. The question was from quantum mechanics. The state wave function was given. It was obviously for the electron. We need to find out this expectation value, which is Lz plus Sz. Okay, now we know that if Lz operates on this spherical harmonic, we get mh cut and ylm theta phi, and if Sz operates on x plus or minus, we will get h cut by 2 eigenvalue. Okay, so now operating this, first of all we are going to operate this Lz to these two function. Now we know that Lz gives us mh cut, so it has to do with only m. Here value of m is 0, so it will give us 0. Now if this Lz operates on this one, here m is equal to 1, you can see. So for that we will get eigenvalue h cut, and this will get squared. Okay, So multiplied by 5 by 8. Now comes the sz operator. If sz operates on this, here it is x minus, so it will give us 3 by 8 minus x by 2. And if this sz operates on this, so we will get 5 by 8 into plus h cut by 2, because this is x plus. By just adding these terms, we will get 3 by 4 h cut. So that was the answer. Now moving on to the next question. The question was, a particle moves under potential V of r is equal to minus k by r, k dash by 3r cube. Its angular momentum is L. For stable equilibrium, how k dash L should be related? So we know that effective potential, we can write it as V of r plus L square upon 2mr square. So here V of r is minus k by r, k dash by 3r cube, and this, okay. For stable equilibrium, we need to differentiate it. So after differentiation, we will get this thing, okay. And after multiplying it with r raised to 4, we will get this expression, which is nothing but a quadratic equation. So by rearranging this term and applying this Sridharacharya's formula, which is x is equal to minus b plus or minus under root d upon 2a, we will get this expression. Now to get this stable equilibrium, this term must be positive or 0. That means L raised to 4 upon m square minus 4k dash is greater than 0. And by just taking this term over here, we will get 4k dash is less than L raised to 4 upon m square. And from here we get this answer. That was the answer. Now moving on to next question. The question was, a particle moves under the potential V of r beta r raised to k. For stable orbit, L was given, obviously k and r0 will be what? Okay, so we know that it is a central potential and its orbit must be circular orbit for it to be stable one. So we effective, we can write it as beta r raised to k. This again we need to differentiate it and equal to 0, and from here we'll get this expression, okay. And in the option there were k is equal to 3, k is equal to 4 I think, and k is equal to 2, but only k is equal to 2 can satisfy this equation. So answer will be k is equal to 2. Now moving on to this question, Hamiltonian of system is this and potential, okay. We need to find the Lagrangian. So we are not going by this method, which is x dot p minus a. Instead we are doing something else. So here Hamiltonian, we can rewrite it as, here you can say e raised to minus x upon a. So if it comes to denominator, it will become positive, okay. So from here we can analyze that this is nothing but mass, okay. M e raised to x by a is mass. So we can write Lagrangian as half mv square minus v of x. So here mass we can write it from here, which is m e raised to x upon a x dot square minus vx. So that was the answer, okay. So these were the questions. Here question number 2. A long wire lies along z-axis on xy plane. Find v of rho plus a minus v of rho. So I think this question was very easy, because we know that electric field of long wire, we can write it as 2k lambda upon r or lambda upon 2 phi epsilon naught. Okay, some type of this we can redraw the diagram as, let's say here we need to find the potential. This is distance r, okay. We can write electric field as minus del by del r is equal to lambda upon 2 pi epsilon naught r. By differentiating it, we will get this expression, okay. But we need to find this v rho plus a minus v rho. So what we are going to do, we are going to plug here first rho plus a and then simply rho. So by plugging in rho plus a, we will get this expression, okay. Or we can write this expression, let's say equation number 1, and by plugging just rho, we will get this expression, let's say equation number 2. By subtracting these two equations and calculating it, we will get this expression, but we know that we can write log 1 plus x as x minus x square by 2. Basically in x we are expanding it, okay, but in question it was given that, okay, so we will just take this first term. So we can write L1 plus x is equal to x, and if ln 1 plus a by rho is given, we can write it as simply a by rho. So here ln 1 plus a by rho was given, so we can simply write it as lambda upon 2 pi epsilon naught a by rho. So this will be the answer. So guys, I hope that you liked my video, okay, please share this video with your other friends so that they can get this solution, and please subscribe because I need more subscribers. Let's aim for 1k subscribers, okay. Thank you for watching and please sharing.